Okay, derivatives of inverse trig functions. All right, so do you guys remember from pre-calc, like you talked about inverse sine and inverse? All right, do you remember talking about this? So inverse sine, do you know what it looks like? So like the normal sine function goes like this, yeah? And it goes from, like we say it's 1 to 1, it passes the horizontal line test from here to here. Okay, so the inverse sine function ends up being a reflection of that over the line y equals x. Okay, so you've talked about inverse sine. It's restricted from negative pi over 2 to pi over 2. If you think about it on the unit circle too, it makes sense. Like, where do you have every single value for sine? Sine is the y coordinate on your unit circle from here to here, right? Every single value for your y value is represented from there to there. But once I go over here a little bit, now I have repeats. I don't just have one answer, one y value. Okay, so that's why it's from negative pi over 2 to pi over 2. So it's restricted on that domain. So if you have inverse sine of x equals y, that happens when sine of y is equal to x. And your y value, your angle, has to be between negative pi over 2 and pi over 2. So you can cancel things. You can say inverse sine of x equals x on that interval negative pi over 2 to pi over 2. And sine of inverse sine of x as long as x is between negative 1 and 1. Okay, but it doesn't always work that way. Like, they don't always cancel each other out. So this is what I always hated when I was in school, because I'm like, why don't they always cancel out? So we'll skip this part and we'll go over here. So why do we have this? This equals pi over 4, but this does not. Do you guys remember that from pre-calc where you always like, why don't they just cancel? I hated that in pre-calc. All right, so let's think about this first one. So if I have inverse sine of pi over 4. Okay, let's start on the inside. Sine of pi over 4. Nia Townsend, what's sine of pi over 4?
I got this. 2 over 2 over 2.
Thank you. I knew you knew it. All right, so let's think on our unit circle. We're only thinking on the right side of our unit circle because inverse sine is restricted to that one side. Basically, like if you use your calculator for arc sine or inverse sine, it gives you one value out. It doesn't give you multiple angles or multiple angles. So you're saying, for what angle do I get a sine value of root 2 over 2? It would be right here, correct? Do you guys agree with that? Okay, now there are other places where you would get a sine value of root 2 over 2, like over here, right? But there's only one angle. For an inverse function, there's only like one answer that you're going to get. You're not going to get two answers. So it's really only just this one.
Negative root 2 over 2 would have worked then.
Right. Well, it would be down here. It would be down there. All right, so we want our answer to be between negative pi over 2 and pi over 2. We want pi over 4. So if you use your calculator and you did inverse sine of root 2 over 2, it's going to give you pi over 4. It's going to give you like the decimal version, but you'll get pi over 4. Okay, but why doesn't that work for this other one? So if I have inverse sine of 7 pi over 4, why is that not equal to 7 pi over 4? So let's start on the inside again. What is sine of 7 pi over 4? Negative root 2 over 2, right? Because it's down here, right? But then arc sine or inverse sine is restricted on a certain domain. It's restricted between negative pi over 2 and pi over 2. All of our answers are going to be between there. So what value between negative pi over 2 and pi over 2 gives me negative root 2 over 2? It has to be between those two things. It's not 7 pi over 4, is it? What is it? Nope. It has to be between negative pi over 2 and pi over 2. Negative pi over 4. This is why you guys learned coterminal angles, reference angles, all of those things in pre-calc. Do you remember those words? Okay, yes, this location, that's the same as 7 pi over 4. Do you guys agree? It's the same place. It's 7 pi over 4. That's where it's located. But if you did this on your calculator, if you do inverse sine of negative root 2 over 2, it is going to give you negative pi over 4. It's going to give you that one answer because that's there's only one value between negative pi over 2 and pi over 2. That gives you root 2 over 2 when you plug it in. Okay, so it has to be on that interval. So if we go back to cosine, so kind of go back, cosine looks like this. Ooh, I missed it. I'll just put my axis right there. I'm picky. I'm still going to miss it, I bet. Yep, I did. Okay. So anyway, I want the place where it's going to be 1-to-1. The word 1-to-1 means passes the horizontal line test. So I want the place where it's going to have every single value. Okay. But it's not going to repeat. So do you guys see how you have every single value between here and here? Like it passes the horizontal line test. But I don't have a place where I had 2 that gave me the same height. You see what I'm saying? Like if I extended it and it went down, if it went down here, now I have 2 points that have the same height. You see that passes the it fails the horizontal line test. Okay, that's not 1-to-1 then. So from 0 to pi, cosine is 1-to-1. So it says the inverse cosine function or the arc cosine function is restricted to the domain 0 to pi. Okay, so its function is going to be it's hard to draw because it's always a reflection of the line y equals x. So how do you draw it? It's really hard to draw. But it ends up being the inverse of that. Okay, so of the cosine function, it's going to be the inverse. Remember how you switch your x and y values? Okay. So it says find the derivative of y equals inverse sine of x by changing the form of the equation and differentiating implicitly with respect to x. This is kind of weird. We're going to do this one time. You're going to find the derivative by hand, like this long way. And then we're going to discuss, we're just going to use the shortcut. We're going to know the derivative after this, okay? So it says find the derivative. So I have y equals inverse sine of x. Okay, if I change it around, I'm going to get sine of y equals x. That's from the cancellation formula. So we're restricted on a certain domain when we're doing this. Okay, I'm going to take the derivative implicitly. It's been a while since we've done this. The derivative of sine of y implicitly is going to be cosine of y times dy over dx. And the derivative of x is 1. So dy over dx ends up being 1 over cosine of y. But we don't want y in our final answer. Okay, we want to have just x's. So this is where it gets a little strange. Do you guys remember your favorite thing? I've asked you about this multiple times. Yes, oh, you're so good now. Look, you guys all got it. All right, so let's say these are y's. Same idea, right? They could be y's. And I want to solve for cosine. I would have 1 minus sine squared y equals cosine squared y. And if I would just want cosine by itself, I have to take the square root, right? So I'm going to do square root. And every time I do a square root, I'm always a good calculus student, and I write plus or minus. Okay, so I get cosine of y is equal to plus or minus the square root of 1 minus sine squared y. Okay, we're talking about arc sine. And we know that arc sine is restricted to this side of my unit circle. Okay. Well, on the right side of my unit circle, are your cosine values positive or are they negative? They're positive, so we're going to select the positive. So in other words, dy over dx, so going back here, is equal to 1 over the square root of 1 minus sine squared y. But I still don't want y's. So I do one last thing. So I say dy over dx equals 1 over the square root of 1 minus, and I go back here. What do I put in place of the sine squared y? X squared. You guys see? Because it was sine of y squared. Because if I square both sides, x squared is sine squared y. Like, what is sine of y? Sine of y is x, but I had sine squared y.
Oh.
All right, so you end up getting this.
How do you get
Because sine of y is equal to x, so I replace sine of y with x, so I get x squared. All right, long process, right? Much easier if you just remember that the derivative of inverse sine is 1 over the square root of 1 minus x squared. Can you guys do that? Make your little flashcards. Yep, some of you love some flashcards. All right, let's do the same process for inverse cosine. Do you guys want to try it on your own first? See if you understand it. You just want me to do it? Okay, same idea. So we're going to say y equals inverse cosine. And we're going to switch forms. So we're going to say cosine of y equals x. And we're going to take the derivative implicitly. So the derivative of cosine of y is negative sine of y. But it's a y term, so I need my dy over dx equals 1. So I get that dy over dx is equal to 1 over negative sine of y. But I don't want y's, I want x's. So I go to my magical formula. Cosine squared y plus sine squared y equals 1. I don't know why I wrote it backwards. You guys usually say sine squared plus cosine squared, but whatever, you get it. So if I want to solve for sine of y, I have to get the sine of y by itself, right? I'm going to subtract the cosine squared over. So I'm going to get 1 minus cosine squared y equals sine squared y, and I'm going to take the square root. So I have sine of y equals plus or minus the square root of 1 minus cosine squared y. Now I make a decision. Do I use the positive or do I use the negative? So I look back here and I say, well, it's inverse cosine. And on my unit circle, where do I have every single cosine value? Every single x value with my coordinates. Where are they represented? On the top. Does that make sense? It's up here. From 0 to pi. Are the sine values positive or negative? They're positive, so I select the positive ones.
Wait, oh, I thought over there it's not.
The y values are positive though. Yeah.
Why is it on the top? They're both sides. They're both
Because inverse cosine is restricted only to the top.
with one.
Why not the bottom? It's just the way we defined it. Yeah. When they first created inverse cosine, they made that distinction. That's why every single calculator gives you those values. Yeah. It's weird, isn't it? Yes.
So, is that something that we just automatically know?
You guys should know inverse cosine and inverse sine. Did you guys ever talk about those in pre-calc? Showed you where they are on the calculator. All right, dy over dx equals 1 over negative sine of y. So it's going to be the square root of 1 minus cosine squared y. Okay, almost done. We said cosine of y was equal to x, right? So we plug in. So I get 1 over negative square root of 1 minus x squared. Okay, and you could repeat this process for all of the different things, for inverse tangent, inverse cosecant, whatever you want. All right, but what I'm going to tell you is luckily the AP test only uses 2 of them. Okay, they use this one, and they use this one. Those are the 2 you need to know, sine and tangent. I'm not saying that this year they won't be different and they won't put some other ones on there. Remember I told you the AP test gets harder every single year. You never know what they're going to give you. But in the past, historically, they have only done those 2. A couple years ago, they didn't do any of them. One year they put it on a free response, though. That was rough. Ooh. All right, so I would recommend memorizing those 2. So memorize inverse sine and inverse tangent. Okay, so they can be in weird forms. I mean, like I can tell you if y is equal to inverse cosine of x to know the derivative, and you would say it's this one. But it's not always going to look like that, right? It's going to look different. Like this first one is 1 over inverse cosine of x. Don't say that's cosine. Don't try to get fancy and be like, oh, it's just cosine. No. Inverse cosine, the cosine to the -1 does not mean 1 over cosine. Right? That's secant. Don't do that. You guys all know that at least? Did you all learn that in pre-calc? No? Okay, so, oh man. Okay, so y prime is going to be low, d high is 0, minus high, d low. All over the square of what's below. I would at least try to cancel out this first part, right? So that first part's gone. It's 0. And you have a negative times a negative, so you get a positive. So you have 1 over the square root of 1 minus x squared. And then you have over inverse cosine of x squared. Now, it's really like not nice to leave a fraction within a fraction. Just like with numbers. Like I don't say 1 over 3/4, right? I would write 4/3. That's just kind of weird. We don't do that. So one last step. So this is like this thing divided by the cosine, inverse cosine squared. Okay, so it ends up being 1 over the square root of 1 minus x squared, and then times inverse cosine squared. Why did I do it on the bottom? Is that what you said?
Yeah, like why did you multiply the cosine negative 1x only on the bottom and not
Because it's like dividing by cosine squared, inverse cosine squared, which is multiplying, yeah, by 1 over, like that. Does that make sense? So that's your answer. You can't say it's cosine to the -2 either. When in doubt, think of cosine to the -1 as arc cosine. That's how they used to write it. Like if you see these things, they're equivalent. That's the same thing.
Like the next one. Yeah.
Yeah. Mm-hmm. Yeah, back in the day when we used typewriters instead of computers, it was a little hard doing those exponents.
Right.
So we wrote arc cosine. Yes, I used to type on a typewriter.
Really?
And then I moved up in the world to a word processor. This tells you how old your teacher is. All right, so find the derivative of y equals x times arc sine of x. I did. It was terrible. Imagine proofing your papers on a word processor when the screen's like this big. It took forever. All right, so I have x times inverse sine of x. That's what that is. Arc sine is the same as sine to the -1. Inverse sine. Okay, so I'm going to have y prime equals first times derivative of the second. So the derivative of inverse sine, 1 over the square root of 1 minus x squared, plus derivative of the first is 1, second normal is inverse sine of x. You can leave it. So you could simplify a little bit. You could do the x on top and then get rid of the 1. But that's fine. Okay, I'm going to give you a couple more. Because I think on your homework I put a couple hard ones with chain rule. So what if I had inverse tangent of 2x cubed? Inverse tangent, if I have inverse tangent of u, its derivative is 1 over 1 plus u squared. But remember, don't forget your du. So in this case, I'm going to have y prime equals 1 over 1 plus u squared times du. What's du? No one? 6x squared. This is your u, right? One more. You didn't answer very quickly. It worried me.
Why is it 2x cubed square root of
You got it? Yeah, and then you could clean this up a little bit, right? Okay, so let's say I have this one. Y prime. This is something being squared, so it's going to be 2 times the something, so I keep that inside exactly the same, inverse sine of 3x. But then I multiply by the derivative of the inside. The derivative of the inside, that's in the form inverse sine of u. If I have inverse sine of u, its derivative is 1 over the square root of 1 minus u squared. So I get 1 over the square root of 1 minus u squared, right? The 3x is being squared. And then last step, times what? 3. That's your answer.
So why is the other one times like 12 then?
Because there was only one u, there wasn't like 2 u's. Yes, I went to homework.